In this video, we are going to go over geometric transformations. We're going to go over the rotation. A rotation. So a rotation is a turn around a fixed point called the center of rotation. So on this example here, we start with this image and we rotate it over here. So we're rotating counterclockwise. This point right here is the center of rotation. So this is the point in which it pivots. The figure rotates at a specific angle and direction. Okay, two different directions you might see. We have clockwise, which is going to go around this direction. And to help you remember that, create a clock. So we have 12, 1, 2, 3. And as the hand moves, it moves in this direction. Okay, so like the clock. Counterclockwise is going to be the opposite of clockwise. So counter, think of opposite, clockwise. So again, you can go ahead and write a clock out if you need to help you, and then look at it and be like, well, the clock should go this way, so counter is opposite, means it's moving in this direction. And this transformation will result in congruent polygons, so meaning this shape and the new shape that it creates are going to be congruent, okay? They're going to have the same angles, they're going to have the same side lengths, they're going to be completely identical. This is just rotated, this is just a turn of this shape. Okay, so we are going to go over some rules for rotating counterclockwise about the origin. Okay, so these are the rules only for counterclockwise, though. These only apply to moving each shape counterclockwise. So, 90 degrees. If I start here and I'm ending up here. Okay, so this is the first, and then this is the second. These little angles, it's kind of hard to see, but that is like A prime, B prime, C prime. And this right here is A, B, C. So if I have this shape right here, and I go to this shape, it has moved this direction. The rule for that is X and Y now become negative Y, X. So what that says is when I move from this shape to here, when I rotate it counterclockwise, my original X and Y, my Y will now become negative and it'll turn into my X, and my original X will now be in the second place and end up being my Y. So in a minute we'll go over some of that and it'll make more sense. But this is the rule to help explain what happens mathematically without having to move the object. So now down here, if I am going to move 180, so A, B, C, this is A prime, this is C prime, and B right here. So I moved from here all the way over to here. The rule for this one, X, Y, is now going to be negative X and negative Y. So to go from this point right here where B is, all the way over to this point where B is, the X and the Y stay in the same location and just become negative. So, for example, if this is 4, 2, B, the point is 4, 2, so let's give it an example. So let's go 4, 2. The new B point is going to be negative 4, negative 2. Okay, that is going to be all that happens. So again, here, let's look at this. Let's go back up to the 90 degrees. So this one right here, if this is at 4, 2, our example, the rule states that my new B point here, this coordinate will be at, move over here, the new one will be at negative 2, 4. Okay, I'm just taking the original coordinates and then switching them around as it tells me, and this is where the new B point would be. So moving on down here to 270 degrees. So 270 degrees, rotated counterclockwise. So I went from this one, I rotated around the origin all the way over here. Okay, so the origin right here is the point in which I'm moving all of these. So I have A, B, C again. I end up with A prime, C prime, B. So X and Y now becomes Y, comma, negative X. So again, using the same point, let's say that B was still at 4, comma 2. The new B location would be at, let's see, we have X, comma Y would be at 2, comma, negative 4. Okay, that is where this new dot right here, this new point of B would be at 2, negative 4. From what I have, the X is 4, the Y is 2. So now the Y goes first. So right here, 2, comma, and then make the original X negative here. And that is where I can find this point. Okay, now let's look at this example here. So I darkened the axes so we can kind of see them. And then I already graphed this triangle. So point P is at 3, 7, Q is at 8, 1, and R is at 1, 2. We are going to rotate this 90 degrees counterclockwise. So 90 degrees counterclockwise, it needs to go this direction. And 90 degrees is only moving it from this square over here to this square. I am rotating about the origin. So when I rotate it, if R is closest to where I'm rotating it, R is still going to be closest here. Okay? I'm just taking it and moving it over. So let's look at the rule for rotating 90 degrees counterclockwise. And I know my original X, comma, Y is going to be negative Y, comma, X. Well, let's look at that now. So P, right here, I have 3, 7 is my original. So if I take that and I'm going to go negative 7, 3 is where the new point for P is going to be. So let's go over negative 7 and 3 up. Here is my new location for P. Now looking at Q, I have 8, 1. Well, 8 would be here, 1 would be here. So let's apply the rule. So it would be negative 1, 8. Now let's graph that. Once I graph that, Q would be right here. Okay, R, I have 1, 2. Well, let's go ahead and apply the rule. I will have negative 2, 1. And if we go ahead and graph that, so negative 2, 1, be right here. That is where R is. There is the new shape rotated 90 degrees. And see if it'll let me do this here. A kind of way to explain that is if I took this shape here, turned it, and rotated it over, it would end up right about at all the points that we just put. Get rid of that. So this shape turned and rotated over here. The R is still the closest. This is rotated 90 degrees. Okay, now let's look at this second example. If we look here, we can see we're only rotating 180 degrees. Well, 180 degrees counterclockwise or 180 degrees clockwise, regardless, it's going to end up down here, right? The same rule applies. I can go clockwise or counterclockwise. I'm still going to get there the same way. So let's look at the rule that we were given to rotate 180 degrees. We know the original X and Y, 180 degrees, goes 80 degrees to negative X, negative Y. when moving 180 degrees. So we want to go from here all the way down to here. Okay, all we have to do is change the coordinates to negative. So W is 2, 3. It'll be -2, -3. X is 5, 8. It'll be -5, -8. Y, 7, 6. It'll be -7, -6. And Z, 8, 2. It'll be -8, -2. Now, I should be able to take these points, graph it, and it should show that this has rotated all the way down here. So let's do that. Okay, once I graph all of those new points, I can see that this shape does indeed end up in this quadrant. It has just rotated, and since this is the center of rotation, W is the closest here when I start. W still needs to be the closest here because it is still rotating around in the same orientation with the same points. It's close to the center of rotation as it was when it started.